Well, hi there, boys and girls. Today we're going to give a little shout out. Got a picture of Eric. Eric here is in his room, and he says, you can see here, he's bored in his room. And so he says that I need some air, so I'm going to go outside. And so he leaves his room and he goes outside to get some air. And when he goes outside, he sees that there's a dinosaur like under a rock. But the dinosaur's too big to hide under the rock, and Eric's like, "You're not a scary dinosaur. You're too tall to hide under that rock." And so the dinosaur was all worried. But then they made friends, and so Eric made a friend with the dinosaur. And he told him, "Man, you're too tall." And Eric's like, "Hey, look at that building over there, Mr. Dinosaur. I wonder how we can find the height of that building without actually measuring it." And the dinosaur says, "Well, that would be really easy with trigonometry." And so Eric's new friend teaches him the law of cosines, and they're happy together, and so they were friends forever. Alright, so here we go. You need to learn how to find missing sides and angles for things that are not right triangles. And things that are not right triangles, that means there's no little box inside the triangle, there's no right angle. These are called oblique triangles. And in geometry, you only learned how to deal with right angles and use Pythagorean theorem and things like that. And we've used Pythagorean theorem in SOHCAHTOA. And now we're going to investigate triangles that we can't use SOHCAHTOA because there's not a right angle. So what we're going to do here is we're going to start with a triangle. And I just want you to, we're going to review some things here. If I have a triangle and I have three sides, I'll call those sides A, B, BC, and AC. A shorter way to label these sides is to put a little a across from the angle. So side A is across from angle A, and side B is across from angle B, and side C is across from angle C. That little pause was because I had to get up and grab my notebook. Sorry. All right. Notice that these angles are here, they're all acute. There's no right angle here, but you could have bigger than 90 degrees, less than 90 degrees, but notice there's no right angle here. And your formula that you're going to use is called the Law of Cosines, and it's an adaptation of the Pythagorean theorem. And so I'm going to show you how to use this. There are three forms because it depends on whether or not you want to find side A or angle A, or side B or angle B, or side C or angle C. It depends on how you draw your triangle. So notice that all three of these start with the Pythagorean theorem. They just add a second thing in, minus 2bc cosine of the angle, or depends on where you're orienting yourself. So let's start with the picture and do an example of this. Let's have a triangle that's not right. You're not right triangle. And I'll put a 70-degree angle right there. And to let side B be 8, and I'll let side C be 6. And we want to find side A. So what we're going to do, we can't set up SOHCAHTOA here. We are going to have to use this formula. And this formula says that side A squared is equal to side length B squared. Notice the side lengths are lowercase and the angles are uppercase. So I'm going to have A squared is equal to B squared plus C squared minus 2BC cosine of angle A. Please notice that all of this stuff is together. You can't subtract 2 from the C squared until you've done all of this. So let's answer this. A squared is B squared, B is 8, plus 6 squared minus 2 times B times C times the cosine of the angle A. Let's go through here and answer some things. 8 squared, of course, is 64. 6 squared is 36. 2 times 8 is 16. 16 times 6 is 96. Times the cosine of 70 degrees. And again, please, you have to keep these together. You cannot subtract the 96 from the 36. Some of you will do this in class, and I'll refer to the video and say, remember, you can't do that. You've got to multiply before you subtract. And so we'll keep going with this. A squared equals, we can add the 64 plus 36 together because they're not attached to any multiplication statements. And so I get 100 minus 96 times the cosine of 70 degrees. And I'm going to solve this for A by taking the square root of all of that on my calculator. And this worked out to be about 8.2. So we found the missing side length in a non-right triangle. Non-right means oblique. And I also want you to notice that this triangle was a side angle side triangle. We knew one side length, we knew a second side length, and we knew the included angle between them. This is a perfect example for when to use the law of cosines. All right, let's keep going with this one, and let's find the measure of angle B. So we can also use the law of cosines to find missing angles. Notice we don't know the angle for B. So we can find this by still using our formula, but I'm going to go back up to the formula, and I'm going to use the formula that's got the B in it. So that formula says that B squared equals A squared plus C squared minus 2AC times the cosine of angle B. Please notice that this is all together. You cannot subtract the 2 from the C squared. So for my picture, I'm going to have B, which I already know is 8 squared, is equal to, I found A to be about 8.2, so I'll plug in 8.2 for A. 8.2 squared. Plus C squared, C is 6, so 6 squared is 36, minus 2 times A times C times the cosine of the angle B. And I don't know that, so I'm going to keep that as angle B. Alright, so let's keep doing some math here. 8 squared is 64. 8.2 squared works out to be 67.2 plus 36. And then all of this, 2 times 8.2 times 6 is 98.4 times the cosine of angle B. Please notice that this is all together. You may not subtract that from the 36. Some of you will do it in class, and I will tell you you couldn't have done that because you're supposed to multiply before you subtract, or you shouldn't have done that. Alright, so let's keep going here. 64 equals 103.2. That's what 67.2 plus 36 is, minus 98.4 times the cosine of angle B. Now I am still trying to find measure of angle B, so I'm going to subtract 103.2 from the 64. Please don't subtract the 98.4 from 103.2 because it's attached to this cosine of B. That's like the third time I've implored you not to do that. So once you make this mistake, I'm going to draw a sad panda on your sheet of paper. So if we subtract 103.2 from both sides, we get negative 39.2, I think that is. And this is equal to minus 98.4 cosine of angle B. Now I'm still trying to find angle B, so I'm going to divide both sides by negative 98.4, and I will get that 39.2 divided by 98.4 equals the cosine of angle B. And so how am I going to find angle B? I'm going to arc cosine both sides. So the measure of angle B is going to be the arc cosine of 39.2 over 98.4, and that works out to be about 67 degrees. So you can find missing sides and angles without a right triangle. So we're not going to be doing SOHCAHTOA, we're going to be doing this law of cosines. And again, I want you to notice that side angle side was something to start with, and why would you want to use the law of cosines? We're going to do word problems with this stuff. Well, one use of law of cosines is if you had a lake over here, and you had this lake, and you knew this angle C and the side length B and A, and you wanted to find the distance across the lake. If you look in a almanac, it says the distance across this lake is blah, or the length of this lake. And I'm always curious, how do they measure that? Because it's not like they get out there on a little ski boat and have this great big long measuring tape. You can use the law of cosines to find distances across something that you can't physically measure. This is called surveying and things like that. You could also, if you wanted to, maybe find like the length across somebody's nose. So anyway, I will see you guys tomorrow.